James Webb Space Telescope Grazy discovery about Hawking. Undoubtedly, the James Webb Telescope will provide a wealth of much expected information, however, it will take decades to accomplish its principal goal. The James Webb Space Telescope, or JWST, is already collecting data to answer these questions. In the top spot, what was the universe like in its infancy? In the second place, when did the first galaxies and stars begin to form? A total of 3. The first galaxies evolved throughout time in what kind of way? The fourth, what causes stars to form? The fifth is just how many of them form and how big they all end up being. This is the sixth one, for example, how does a star go out? Digit 7 of the 13, in what environments and conditions do new planetary systems emerge? Finally, the 8th digit, how much can we learn about dark matter and dark energy from this? Learn about the shocking finding of Hawking radiation made possible by the James Webb Space Telescope in this short film. The testing of one of Stephen Hawking's most contentious theories and his thoughts on black holes on March 14, 2018, a new study that shows physicist Stephen Hawking died after a long and illustrious career. The most impressive work of the latest cosmologists was primarily concerned with black holes. These intruding cosmic vacuum cleaners defy so many physics concepts, or what we think the cosmos should look like, or excellent cosmic vacuum cleaners that defy so many physics concepts, or what we think the universe should look. Hawking's contributions range from discovering that black holes aren't black to their hair that may emitted by them. Hawking was a master of defining the data. Let's go back in time. Hawking postulated in the 1970s that dark matter, the invisible component that makes up most stuff in the universe, may be constituted of black holes generated in the early moments of the Big Bang a few decades ago. 3 astronomers have come up with a theory that the presence of dark matter and the appearance of the most significant black holes in the universe is similar to Hawking's research. A Yale astrophysicist and study co-author, Priya Mandara Nadarajan, said in a statement that excited about this idea because it elegantly unifies the 2 challenging problems that are work on the probing of nature of dark matter and the formation of growth of black holes, and resolves them in one fell swoop. The James Webb Space Telescope, which was recently launched, is one of several new pieces of equipment that could provide the data needed to evaluate Hawking's famous hypothesis. Researchers are confident that the James Webb Space Telescope, formerly known as the Next Generation Space Telescope, has the instruments necessary to get the desired results. One of the JWST observatory's primary components is an Integrated Scientific Instrument Module, ISIM, an optical telescope, OTE, and the spacecraft bus and sun shield. To shield its instruments and telescope from the sun's light, the 6,200-pound JWST observatory has several vital features, including a 6.5-meter primary mirror made of 18 segments of gold-coated beryllium mirrors, a giant shield the size of a tennis court, and a wavelength range that includes infrared, mid-infrared, and ultraviolet light. Hubble's pointing and stability requirements are far less stringent, making it easier to use. It's tempting to believe that black holes are to blame for this enigmatic matter, which accounts for roughly 80% of all matter in the universe, yet has no direct interaction with light. Instead, it exists as vast emptiness that affects the gravitational pull of galaxies. Because black holes are notably dark, filling a galaxy with them might theoretically account for all observed dark matter. But this is not the case in the contemporary universe, where massive stars die and collapse under the weight of their gravity, creating black holes instead. That's because producing black holes requires a lot of stars, which means a lot of ordinary matter, where the initial hydrogen and helium produced have been calculated by scientists. They know how much ordinary matter is in the universe, and when the numbers are tallied, it is evident that there is not enough ordinary matter in the cosmos to support all the black holes observed, in addition to what we know to be dark matter. According to Hawking, black holes may have been produced in the early universe, who postulated that pockets of matter might spontaneously attain the density required to generate black holes in the chaotic environment of the Big Bang. Black holes and their relatives, black matter, would then be released into the cosmos before even the earliest stars could begin to shine. Most astrophysicists instead focus on finding a new subatomic particle to support dark matter. Collaborators observed that the primordial black hole development models ran into observable concerns of too many developed in the early universe, so they reworked the cosmic microwave background, or CMB, which is generally known. The theory only worked when the number and size of the earliest black holes were minimal. With that restriction in place, observations of CMB were inconsistent. Still, in 2015, the Laser Interferometer Gravitational Wave Observatory identified its first pair of colliding black holes, proving Hawking's prediction that black holes are cannibalistic. In the early cosmos, black holes were not generated in the dying hearts of stars. Scientists from Yale University, the University of Miami, and the European Space Agency organized a task force to test the notion of primordial black holes in their experiments. preliminary black holes were supposed to have masses over the sun, they built a model of the cosmos in which these relatively light black holes replaced all of the dark matter, and then they looked for evidence to confirm or rule out the concept. According to the research team, prehistoric black holes may have seeded the universe's initial stars, galaxies, and supermassive black holes with the acronym SMBAHS, supermassive black holes. Observations show that the emergence of galaxies and supermassive black holes throughout our cosmic history has been rapid. The Milky Way's central black hole may originate in primordial black holes. Natarajan said that the idea is simple and does not require a menagerie of new particles to explain dark matter if primordial black holes exist. The work of Capilouti and colleagues indicates that the nature of dark matter and the genesis of supermassive black holes can be explained without introducing new particles or new physics. Even though at this point it's simply an idea based on a model. It will soon be tested using the James Webb Space Telescope and its laser interferometer space antenna, which has been created expressly for this purpose. If primordial black holes exist, the James Webb Space Telescope will reveal more about them. A happy occasion has arisen. A new observatory, the James Webb Space Telescope, is on the verge of providing astronomers with the information they need to piece together a story about our universe's first stars, and perhaps the origins of dark matter. And Natarajan had to comment on it because it was irresistible to explore this idea in depth knowledge that it could be validated fairly soon, and to think Stephen Hawking probably had it all correct along. His other outlandish theories concerning black holes and black stuff have piqued the interest of scientists, so the idea that black holes have here is a particularly memorable one. Hawking and Harvard University physicist Andrew Strominger proposed in 2016 that black holes have a lush crop of air that was previously assumed to be missing from their edges. This was a metaphor for the event horizons emitting lengthy strands of zero-energy particles. Hawking's next crazy thought is that black holes may erupt and fizzle out. Hawking introduced the concept of Hawking radiation in the 1970s, which suggests that black holes may eventually dissipate rather than expand over time. According to this theory, matter and antimatter particles will appear out of thin air and subsequently annihilate one another at the black hole's edge. To avoid being destroyed by its antimatter companion before entering the heart of the black hole, a particle can appear on the edge of the black hole and shoot out into space. The black hole may leak and shrink in size if this continues for an extended period. This suggests that substantial black holes may be ejecting light. Hawking radiation is yet to be precisely measured, but most physicists believe it does exist. Since knowledge is more power and science isn't settled, be sure to comment for more extraordinary details about the mysteries of space. Smack that like button if you agree with Hawking's predictions about black holes. Are they primordial? Do they have hair? And can they fizzle or deflate? Become a member of the Space Infinity community, share this video, and get unlimited access to the Space Infinity archive.